Okay, double check that I am actually live. Yes, I am. All right. Fall 2024. Another season of Mike Talks to Himself. Welcome back, folks. Got a new fancy Discord. We'll see if people actually show up and talk. Obviously, I got to give students the right to say no if they don't want to be recorded. But I need to get to work here. I have been so lazy the past week. Well, not lazy. I've been working too hard, honestly, because it's been the beginning of the semester. And I know some of you are saying, Professor, why are you doing this garbage when you should be doing my grades? Peace, young grasshopper. I will get to your grades. I will get to your grades. I have a graduate assistant, and she is going to be awesome and help me with them. Until then, I need to find sanity where I can. And after a day of dealing with incidents, well, not a day, but an evening, I need a second. I need a second to recompile. Let's go with that. Recompile. We're going to recompile here. I know I said I was going to start out with Lua again, but that's a lie. I'm going to go with Python because I'm lazy and I have not touched programming in probably 2 or 3 weeks when I was fixing my soup bot, which is not even a real program. Oh man, they changed the challenge on me since I changed the language. Oh, bummer. All right, whatever. Chat's over there. And no one's watching. Cool. So I can just do whatever I want here because no one's watching. YouTube can't do shit about it. What are they going to do? Demonetize me? No money, bitch. All right, so what do we got here? What are you going to throw at me? What do we got? Come on. Give me something good. I need something that'll take my mind off. Digital root is the recursive sum of all the digits in a number. I'm going to do that like 5 times because I'm paranoid and I keep... calm down, Mike. It's been a week. Is the recursive sum of all digits in a number given n, take the sum of the digits n, if that... let's see that a little bit here. Take the sum of the digits n, if that value has more than 1 digit, continue reducing this way. Single digit. Okay. 1. Oh, so just break it up into digits and add them. Or, no, wait, no, it's more than that. I'm skipping. I can't think. I really can't think. Oh, I see. It's reduction and, okay. So they're saying add them up, and then you get a reduced number. And then that reduced number, you do it until it's again. Okay, I get it. Okay, so this is going to be basically some kind of, it's going to be some kind of a mix of a string and a number, right? Because we're treating it both ways. Right? We're taking it as the length of a number. We're thinking about it as the we're thinking about the length of a number, but we're also thinking about the digits, like adding them all up. All right, so digital root then. So first thing we got to do is make it a string. Well, actually, it's going to be given me as a number, right? It doesn't say what data would be, but I guess in Python it doesn't really matter. Okay. But I'm going to assume, let's assume it's an integer. All right, so let's say was wait, actually, let's do this. Yeah, there we go. Okay, so number string n. So for each digit in that number, we're going to add them up, basically. So for digit in number, well, we want a sum, right? So we'll start our sum at 0. Someone's watching, that's cool. Or maybe that's just me, who knows. S equals 0. And we can add to that. So 4-digit in number, add to the sum. Add, it's going to be, we're going to convert it because it's a string. Digit. It says view duration 20 minutes. How's that even possible? Is the stream going? I don't get it. I don't get YouTube. I'm not going to pretend I do. This is just for, yeah, whatever. S plus equals int digit. So we're adding it to that. Digit number. Oh, we could do recursion here, obviously, because you're as long as the length of the number is longer than, well, sorry, as long as the length of the number is not 1, just, okay, yeah. I don't know why I didn't see that right away. Full digit in number, we're going to add to the sum. No, wait, no, it's not that simple. It's not that simple, because you have to pass up the somehow. Be a non-negative integer. Okay. Oh, where'd my thing go? There it is. Maybe I should just keep it like that. I think people can see that, right? Yeah, it's okay. Okay. So no, this is not going to work. Let me rethink this. Hmm. You know, now I'm feeling like it's not recursion. Now I'm feeling it's not. At least not with Python. People are going to be mad at me for this. I know, because people are saying, Mike, it's so obvious. Why are you so stupid? But that's okay. I'm going to do it the fucking hard way with loops. And it's going to be ugly, and you're going to hate it. That's okay. Oh, wait, no, I am stupid. You're not passing the sum, Mike. You're just reducing it. Okay, I'm stupid. That's what it is. Right? You're not adding all the sum. No, yeah. People, I see 2 views. I hope they're not watching this because this is embarrassing. Yeah. Okay. That's how it's got. No, you got to start with this. No, you don't. Okay. So if start with this actually. Oops. If then number 1, return the number. Right, that's going to be our exit condition. Otherwise, you're going to go through this loop. Well, int number. Otherwise, you're going to go through this loop. And actually, that means you probably want... That's not Vim-like. You lied to me. Whatever. Otherwise, we're going to make the sum... Okay, yeah, here's where you want the sum to be 0. Because we're looking at each digit. Each pass, right? Each reduction. So for digit in number, s plus equals the digit. And at that point, well, either it's going to be 1 or it's going to be the other. Well, if it's 1, then you just do that. So yeah, at this point, you would just do digital root of s. Right? The reduction. I don't know why that was so difficult for me. Let's test it. Let's see. Oh, I screwed up something. None should equal... Oh! dumbass. Why does that work? For anybody who's new to Python, you're not a dumbass, by the way. Why does that not work? Let's go into that. Right? What mistake did I make? So here I'm thinking so at this part, right? Start the sum at 0. For each digit and number, add that digit to the sum. Right? Pretty simple. Add 1 plus 4 plus 7 if you're in 147. Then I'm saying call the function on that reduction, but I'm not returning the value, right? So this function would return nothing. So this is saying none should return equal. Should equal 7. None should equal 6. This is saying that I'm getting none because I'm not returning anything for any number that's bigger than 1 digit. I got to return. And there's probably another mistake in here, I bet. But let's see. Oh, there's not. Woohoo. All right, now I can submit it, and let's compare to how bad my solution is compared to everybody else. We're going to attempt it. Yes, I know what I did. I'm correct the mundo. Okay, submit. Okay. See, this is what makes me fucking feel insecure about myself. When somebody posts shit like this, why are you like this? All right, why are all of you like 400 people did this? All right, let's go through how it works, because it is pretty interesting. So he's saying return n if n is less than 10. Okay, because if it's a 2-digit number. Else, you're going to do the root of the sum of the map of int string n. Okay, so map makes so string n makes the number a string. Map makes it a list of integers. Okay, so he's making a list of integers from this. He's then doing a sum of the list of integers, and then he's doing the function, right? And then recursively. So it's the same as mine. It's just he takes up tons of space. Well, it's actually no. Map doesn't really take up space. I'm stupid. I should really learn integrals more because it is better, and what I do is kind of mediocre and stupid. Cool. I don't know why I never think of map and filter and everything. I gotta get more practice with that. What's this one? This one's cool. Return n%9 or nn9. Really? Why does that work? So like if I have a number like if any students are watching and have any questions about stuff, feel free to chime in at any time, by the way. I don't think you do, though. It's okay. N%9 or N and 9. Let me just copy that. It's so weird. N%9 or N and 9. Alright, so let's say it's 16. So N%9 would be what's ever left over. Alright, no, sorry, not what's left over. 9 into the thing. Right, so for this it'd be 7. Wow, that works. Weirdly, right? That 1 plus 6 is 7. Is this just modulo and I'm dumb and didn't see it? Let's say a number like 10, right? You have 1 left over. Yeah, 1 plus 0. Freaky. Okay, I don't know why that works. I'm gonna have to study that again. Man, I'm embarrassing myself. Very cool. Let's see, what else? So it works for those numbers, but why is the or and 9? Alright, so numbers in Python are going to be true if they're greater than 0, right? So, in other words, it's saying if it's not divisible by 9, what the fuck? And 9? 9 is always true. I'm freaking stumped, guys. I gotta go back to school. Alright, Python. How does this work? So you're saying n? Let's say it's a 10. It's like 8 and 9. 9? Okay, I don't understand Python. Let's go into how and ors work again. Python. Oh wait, no, I just realized it's the binary and, right? Is that what I'm not thinking of? Hold on. Right, so calculator. I just forgot what I was doing. Let's see, 9. Nine and wait, sorry, 10 and 9. 10 and 9 is 8. So it's not that either. Python, value of and on numbers. Yeah, no shit, dude. The documentation doesn't come up when you Google this shit. Where's and? Doesn't help me at all, dude. Binary bitwise operations. No, it's not. It can't be bitwise and because that's for something else. I'm very stumped. Let's see. Check 5 first and found it's true. So check the second, return the last one. I mean, that's not fucking said anywhere. Comparisons. Value comparisons. Here we go, Boolean. I don't know, I didn't see that when I searched it, whatever. In the context of Boolean operations, and also when expressions are used by control flow statements, following values are interpreted as false. None, false, none, numeric 0 of all types, and empty strings. Okay, I know that. The operator not, expression and, oh, here's what I'm looking for. The expression x and y first evaluates x. If x is false, the value is returned. Otherwise, y is valued, and the resulting value is returned. X is false. Its value is returned. Well, it would be false, right? So if x is false, that means it's 0 in the concept of numbers. Otherwise, y is valued and the resulting value. So if it's true, x is true, its value is returned. No, I'm reading this wrong. I'm reading it wrong. No, I'm reading or. Stupid. If x is false, the value is returned. Otherwise, y is valued. So that means if x is true. Oh, that's why it works. Okay, I get it. All right, I get it. Let's go through it. So you have something like 0 and 7, right? 0 gets evaluated first. So that means the whole expression is 0 or false. Right? 0 is false. If you do it the other way, 7 and 0. The first one is checked, and that one's true, so it evaluates the next one, right? That's what it says, right? If it's not false, y is evaluated, and the resulting value is returned, right? So that means the resulting value is 0, right? So 0 is false. If something and false, right, that works out, right? But if you have a number and a number, 1 and 2, right, this is going to be true, and it doesn't really matter what the number is, so I guess the programmers just said, all right, just make it the other value, right? We return this value. It's if this one's true, so just return this value because it's going to be true, right? So that actually makes perfect sense. People are probably super cringing at the last 5 minutes, looking at me like going through the documentation, say, "Oh, this is so terrible." It's all there, man. It's all there. You just got to read it carefully. Wow, I had no idea. That's news to me. Cool. We learned something new today. We learned that ands fucking return different numbers in weird situations. That's a cool little trick. I had no idea. Very cool. Let's see. Where's mine? I want to see how bad mine is. Does anyone use my solution? No, everybody knows how to use map. Just me. Just me. I'm the only one who doesn't know how to do maps. Yeah, this guy did another thing like that. Yeah, I'm not going to even bother. It's probably so down there that, like, literally only a noob would think about it. Oh, no, this is kind of like mine. All right, that was a cool one. I learned something new. Very cool. No takers for office hours yet. That's okay. That's okay. I'm going to keep learning stuff. Stoof. Let's go with that. Isograms. An isogram is a word that has no repeating letters, consecutive or non-consecutive. So no repeating letters. That means like it's like garbage. Implement a function that determines whether a string contains only letters. That contains only letters is an isogram. Assume the empty string is an isogram. Ignore letter case. Assume the empty string is an isogram. Okay. Okay, I get it. Let's do it. Okay, so basically what we got to do is we got to go through the word and we got to check if the character that we're on is in the rest of the word, kind of. At least that's that's where my instinct goes. And I'm sure people who are real programmers are cringing at that notion and saying, "Dude, just use a data structure or whatever." That's fine. An isogram is a word that has no repeating letters, consecutive or non-consecutive. One function that determines whether a string that contains only letters is an isogram. Assume the empty string is an isogram. Ignore letter case. But what about stuff that's... Oh, okay. They're saying it only contains letters. Okay, so you can assume that you're going to get a string that only contains letters. Okay, got it. All right. Let's see if I can do this in a clever way. I'm going to stop being stupid and doing like the most basic way of approaching a problem. Well, the first trick I guess you could do is if string doesn't exist, you could return true. Right, so you could return... How would you do that in like a one-liner? Oh, ignore letter case. Oops. I gotta think about that. Alright, so ignoring letter case, first thing we gotta do is lower the damn thing. Assuming empty string is an isogram. So... Is there a way to get unique characters of a string in Python? Let me look at my Python string thing first. Not quite. I don't know if there's like a clever way to do that. Like, let's say we have a word, right? Like, right, how would we fold that word? Well, if you use a list comprehension, you could do something like this, right? X, for X in word, No, hold on. Because how would you say like X is unique? If X is unique. If X is already in the list. I don't know. I think I'm gonna have to do it the dumb way. All right, let's do it my dumb way. So the way I do this the dumb way, I say if there's a string, we're gonna test if it's an isogram. Otherwise, it is an isogram, right? If it's empty, it's an isogram. At least according to this problem. That's how we're coding it. So if string, we gotta test if it's an isogram. So we gotta go through the string, check the other characters, basically. Okay, so we're gonna do for L in string. You want to look, oh wait, hold on. You want to look at the rest of the characters. Or, no, wait. You want to look at all the characters so far. Oh wait, no, wait, you could count though. Yes, that's the way to do it, I think. Or at least it's a dumb way to do it, but you can do it that way. So what you could do is, how does count work again? Is it on the string or the thing? Count. Return the number of times a specified value. Okay, so you do thing dot count the thing you want to count. String dot count the thing you want to count. So we're going to do string dot count L. Wait, no, wait, hold on. If string dot count L greater than 1, not isogram. Turn false. Oh wait, no, I just realized this is now superfluous, right? Because you want to return true if you get there. No matter how you get there, right? So if string, yeah, you're gonna end up here anyway. So no else. Right, so the way that works, lower the string. If there is an empty string, we're gonna go through it. We're gonna count each letter. If any of the counts are greater than 1, then we're gonna return false. In any other case, we're gonna return true. So that would mean even if the string is empty. All right, I think that'll work. Let's see. I am a god. No. Embarrassing. Embarrassing how bad this solution is. It's embarrassing, Mike. It's embarrassing. There's got to be a better way I could fold this. Because this feels weird with all this nesting. This looks ugly. I feel like I could fold this into something. If string. I guess the way you would do this in like a weird way. Well, let me test this. Actually, no. You get the count of each letter. No, that feels weird too. If string would be the opposite case. If not string, right? I don't want to think about it too hard. Let's just see what other people do. Attempt. We've unlocked a new privilege. So cool. So yeah, see? I knew there was going to be an easy way to do it. Set dot string. That is such a good idea. Oh my god. I'm so stupid. I'm so stupid, you guys. Let's talk about how this works. This is so good. So what he's saying here, return the length of the string. No, sorry, no, he's not. Sorry. Return whether or not, whether it's true or not, if the length of the string, of the original string, equals the length of the string that's in a set that's lowered. This is so fucking cool. All right, so here's what set does, right? Set says that you can't have repeats of the same elements, right? It's kind of like I'm not going to bother explaining it. Go look it up if you want to know what a set is, right? It's kind of like a list, but the elements are unique, right? Elements are unique in a set. So what this is going to do is no matter what garbage you have in like string.lower, it could be like this, right? Set is just going to take all that unique shit out for you because that's how it works, right? So when you set this, right, let me put that into Python so you can actually see it. So if I do, so word is this, set word. Look at that, just pulls out all the unique characters in one kind of list, right? So then you know, if this has the same amount of characters as the original string, you got all the unique characters. That original thing had all unique characters in it, right? Because, and the lower thing, what that does is, right, like let's say you had something like this, right, with a lowercase a mixed in there, right? The problem you run into there is that now you have this one, which isn't unique anymore, right? So to solve that, you just lower the word first, which is basically what I did. But these guys are 2,000 people are way smarter than me and thought of that. Man, I'm terrible at Python. Who knew? Who knew? I knew. I don't know why I didn't know. All right, let's go home. Steele's not seeing any takers for office hours. It's been almost a half hour. Let's do one more. Let's do one more, see if anyone shows up. And if not, I want to go play Valheim. Because we got fucking Askfin last night. We got to train that shit, bro. Train that shit. Well met with Fibin. That sentence just came weird off to me. Well met with Fibonacci bigger brother, aka Tribonacci. So the main right field works basically like Fibonacci, but summing the last three. And the worst part. Yeah, okay. So if we start our Tribonacci sequence with 1, 1, 1, we're gonna get 1, 1, 1, 3. Yeah, because it adds the last three numbers. What if we start at 0, 1? Same sequence shifted by 2 places. But that is not the case, and we would get. This one's fucking with me already. Hold on. Hold the phone. What are you talking about now? What if we start with a signature as a scene? Basically shifts the sequence by place. Attempt to think it would get the same sequence. We need to create a Fibonacci function. This is very. Okay. All right. All right, let's think about this. Okay, so the basic Fibonacci sequence looks at the last two numbers, adds them, right? So you're looking at the last three numbers and adding them, which I guess you could do with Python easily with a slice. So I could maybe do something with that. Signature is always going to contain three numbers. Hold on. Let me read that again. What does he mean by that? Does that mean any three numbers? Create a Fibonacci function. Given a signature array/list, returns the first n elements, signature included, of the associated sequence. Okay. This is very oddly written. Well, it's not oddly written, it's just mathematically written. And I am a dummy. Alright. There. Signature will always contain three numbers, but always contain a non-negative number. Wait, what are they talking about? Three numbers. N will always be. Oh, he's saying three numbers, all of those numbers will be non-negative. Okay. I guess that makes sense. So Okay. Okay, so, all right, so we're gonna need some kind of 4 that goes up to n, right? So, how many numbers? So 4 blank, okay, that's for I in range n. Right, so if we want the 5th term, we'll go 5 terms. Wait, hold on. This is going to be weird with the signature. Am I going to have to like make like an if statement beforehand, or can I do this in a weird way? I regret saying I'm going to do one more problem now. So, so no, it's not really iron range. It's iron range length of the signature. But is the signature going to be 3 numbers? Is that guaranteed? Signature will always contain 3 numbers. Okay, so yes, that's guaranteed. So really what you want is n minus 3, right? Because you're only doing a few iterations. You're only calculating the next. So like, let's say you want the 5th element, right? If you're including the sequence in it, because that's what it says, if you're including the signature in it, the sequence, I keep saying different shit. If you're including the signature in it, right? So like, and the signature is 3 things, and you want the 5th term, that means you only need to calculate 2 terms, really. Okay, so we're going to do this twice. No, not minus 2, minus 2. And then what we're going to do is we're going to add the last 3 numbers. So the way Fibonacci usually works is you have like current and starting terms, right? So I guess this feels ugly to do, but you know, actually, no, let's do it this way. So what do we want to call them? Let's say x, y, z equals signature, right? So we're breaking them into 3 numbers. You know, I don't like that. No, because we got to use Fibonacci words, right? So, so Fibonacci uses a current and a last term and a temp term. So this will be the current. This will be the last. I guess this will be the second last. Oh, last 2. All right, that's a terrible name, but we'll go with that. Let's do last 1 and last 2 just to be consistent. So for iron range that, you want to add these up. And that's the new current term. But you need to update the last terms. Okay, so we gotta wait. We might need 2 things to store this. So temp equals, no, yes. No, yes. Temp equals last 2. Because, hold on, no. I think we have to store the last, okay, so we definitely have to store the current one. The current one. Then we're going to say the current one is now going to be the sum of all those. So the current one, the last one, and the second to last one. Now the last one has to become current, or temp, and the last 2 has to become last 1. This feels so ugly, but I'm going to do it. It feels wrong, but I'm doing it. That's literally been the whole lesson of the stream, is it feels wrong, but I'm doing it. God, programmers are just cringing at me. Don't care. I suck at hacking. I don't want to learn how to design software correctly. I want to understand how it works. I want to understand how different code works, different approaches. Don't care about the design. Temp2 equals cur. Temp2 equals the last one. Right, okay. That actually, no, those are good names, I think, right? Because now the last one is going to be temp1. Yeah, okay, wait. So last one is now the temp1. And last two equals temp2. Okay, names last two. Right. Last. Yeah, I think that's it. Right, let's kind of iterate that in manually. Right, so let's say we have say we have signature, let's say, do I really want to copy the code? I don't know. So let's say we start with these numbers, right? So let's say the current term, we start with these, 0 plus 0 plus 1. This guy goes thrown out. This becomes the last term. The new term, so now the sequence is going to look something like this, right? 0, 0, 0. Right, because this is the very first one, the next one, the current one, and now this is the new current one, right? Because we're adding them up. So, oh, sorry, not 0, 0, 1, 1. It's 0, 0, 1, 1, like that, right? Because this now equals the last one. Then after that, you could say, like, the next one after that would be cur equals 0 plus 1 plus cur, which would be 1, right? Let's say cur 1. And now cur is 2. Right, and now we update the last terms, right? So now this one becomes the new one, that becomes the new last one, and now we're going to add the new one. So this one's going to be 1 plus cur plus, well, that was 1. 1 plus 1 plus 2, right? And that gives us 4. I think that makes sense. Let's see if we got it. Oh no, what did I do? I never returned anything, you actual stupid person. What am I returning? I'm returning the whole list? Oh, Jesus Christ. Hold on. I completely didn't read this problem. Very cool. So we're going to have to actually add all these terms to a list now. Okay. So... Are you in Discord yet? All right. So we're going to add these to a list. So... Let's just call it sequence, right? Sequence equals this. Equals that, and we're just adding each term, right? Well, actually, oh, wait, I just realized you have to start with the signature, right? So this is actually just going to be signature, and we're just going to append to that. Would it be better to just append to signature? Maybe. I don't want to change the original list. Sequence. No, let's do it. Let's be dangerous. All right, so we're just going to add this fucking thing to signature. I'm going to return it. Okay. Let's see. Someone looked for like 2 seconds at this stream. That was cool. That was almost exciting. Pass failed 2. What did I fuck up? 1, 1, 1 should equal 1. What was the test? What test did he put in here? 1 should equal 1. Oh, well, I can look at his tests. So the signature is 111. You want to look at the first term. Oh. Well, okay. All right, you got me. Okay, I didn't think about that. I didn't think about that. I didn't think about. Okay. All right, cool. Uh, okay, so I got to think about the case where n is less than the length of signature. I don't know why I didn't think about that. So in that case, I guess you just gotta. I mean, again, it feels so wrong. It feels so wrong to just add ugliness to this, but whatever. I don't know how else to do it. I don't know why my brain doesn't work like other programmers. Whatever. I'll figure it out someday. So if what was I just saying? God. If n is less than 3, then we just return signature. Signature up to that n. Right? Oh wait, no, hold on. Off by 1, right? So let's throw. So let's say signature, let's say it's 1 1 1 2 3, whatever. And let's say we want up to the second term, right? Is that going to be sig up to 2? I don't think it is. It is. I just don't think. Yeah, that works. Okay. I don't know why I didn't think that worked. So up to n should work. That's fine. I think that's it. I think that fixes the one bad condition. It feels so ugly to do that. I hate doing this, but because I feel like when I do this, like it means I didn't think of a better way to do it. Like because like I'm basically saying, oh, here's a special case, right? Just bail out. Then it's just lazy. I don't know. But I mean, sometimes you just have to do that. But I don't know. We're gonna see how embarrassing the solution is soon. We're gonna check it out. Let's see. Let's show me the one-line solution. Give it to me. Give it to me. Give me one liner of how good it is. Oh, it wasn't one line. Let's see what he got. Res is signature up to n. Okay, so it's the same thing. I guess I did, but it's just written condensed. Yeah, people are just good with that with Python. I don't know. Maybe I just got to not beat myself up about that. If the solution is readable, it's readable, you know? But what he's doing is he's saying, go up to that character. If it's higher, obviously it's going to get you the whole signature. Go through the thing and to n minus 3 like I did, right? So you're subtracting off the signature. You're going to just append the sum of the res, what's negative 3? The last 3. Oh, that's really smart. So what this does, negative 3, so it counts back 3 characters and slices them all in a list, right? So let's say you had like a list like this. Right, and that's your current term. What you could do is the negative third of that. Oops, I didn't even do it right. So the negative, well, actually that's instructive, right? So the negative third number is this one, and you want to go all the way to the end, right? So this gets you the last 3 characters. Yeah, it's a smart idea. I do that all the time when I get like extensions of files. I didn't think to apply it here. Very cool. All right, we learned a lot today. I'm feeling pretty good. So nobody showed up. That's okay. I've learned a little bit of something. Maybe you learned a little bit of something too. Maybe you just saw the stream by accident and gave me a view by mistake. That's okay too. I appreciate it no matter what. I think I'm going to sign off for now. We will pick up office hours next week, and once I get to know my students better, I'm sure we'll get some more interesting stuff here. It is just the first week of classes, guys. Nobody wants to talk to their professors. I get it. I'm going to talk to myself in the meantime. That's cool with me. All right, so let me go. Oh, God. I lost OBS. Awkward ending to a stream. End broadcast.